For a punching operation, a cast steel sheet of thickness 1.5 mm is used. So here we are doing punching operation. So generally punching operation is used to produce or form holes in sheet metal. Okay. Na? The diameter of the punch used in this operation is 30 mm. So diameter of punch is 30 mm. So assume this is a punch. So diameter of this punch is 30 mm. The shear strength of this material is known to be 250 MPa. MPa means megapascals. Calculate the following. So first of all, let us note down the given data. So here given thickness of sheet metal. So first given data. Sheet metal thickness. So manaki sheet metal thickness ichadu. How much? Generally denoted by small t is equal to sheet metal thickness is equals to 1.5 mm. Next, given diameter of the punch. Diameter of the punch. Diameter of the punch denoted by small d is equal to how much? 30 mm. 30 mm. Next, shear strength of the material. Shear strength of the sheet metal. Shear strength. Shear strength denoted by tau s. Shear strength tau s is equals to 250 MPa. 250 MPa means megapascal. So we know that 1 megapascal is equal to, remember 1 megapascal is equal to 1 Newton per mm square. 1 Newton per mm square. 250 megapascals then equal to tau s is equals to 250 Newton per mm square. 250 Newton per mm square. Okay. So we need to find two parameters. One is shear area. Find shear area. Shear area. Shear area denoted by AS. And one more quantity is force acting on the punch. Force acting on the punch. A is, first bit is find shear area denoted by AS. Okay, now next we have to find shear force. Force acting on the punch is shear force. That force is known as shear force. So shear area find out shall, next shear force find out shall. Before that, let us draw a simple diagram of punching operation. So there is a sheet metal of thickness. How much is given? Sheet metal thickness. He given sheet metal thickness. Sheet metal thickness 1.5 mm. So thickness of sheet metal 1.5 mm. There is a sheet metal. We are producing or we are forming holes in this sheet metal using some punch. Using some punch. We are producing holes. Okay. We are forming holes. So here given a diameter of punch, how much? Diameter of punch is equals to 30 mm. Using 30 mm diameter punch. Using 30 mm diameter punch. Okay. Using punch we are making holes or producing holes in sheet metal. So what is the diameter of the punch? Diameter of the punch is D is equal to 30 mm. Okay. D is equal to 30 mm. So here diameter of the punch is equal to diameter of the hole. Okay now. So here we are assuming diameter of the punch is equal to diameter of the hole. Okay. So diameter of the hole is D is equal to 30 mm. So here shear strength how much? 250 MPa. So first of all we need shear area. Okay now. Shear, what is the formula for shear? Shear area denoted by AS. Shear area is equal to small p into t. So what is p here? Here p is equal to perimeter of hole. Perimeter of hole. So first of all, here what is the cross section of the hole? In general, cross section of the hole is circular cross section. So for circle, what is the perimeter? Perimeter or circumference? Pi d. So pi into d, where d is diameter of the circle. Here diameter of the circle or diameter of the hole is equal to diameter of the punch, and t means the thickness, sheet thickness. Now as is equals to pi into d into t. So this is the formula for shear area. Now shear area S is equals to pi into diameter of the hole into 30 mm, and thickness, sheet metal thickness 1.5 mm. 1.5 mm. AS is equals to mm into mm square, pi into, so 30 into 1.5, 30 into 1.5 mm into mm square. If you simplify this, you will get shear area is equal to approximately 141.37 mm square. This is shear area. It is shear area. Okay, na? Shear area is equal to 141.37 mm square. Next, we need force acting on the punch, or shear force. Shear force kavali next. So next, B, force acting on the punch. So, or shear force. Simply known it as shear force. Fs. We need shear force. How do you get shear force? Shear force ela vastundi? We know that shear strength tau s is equals to shear force by shear area, or area under shear. Shear force by shear area. So tau s is equal to shear force denoted by Fs and shear area As, A suffix s. From this formula, transpose As. Fs is equals to tau s into As. Fs is equals to tau s into As. Now, shear force is equals to tau s. Shear strength how much? 250 Newton per mm square. 250 Newton per mm square. Into shear area, we got 141.37 mm square. So, numerator mm square, denominator mm square get cancelled. Fs is equals to 250 into 141.37 newtons. If you multiply these two, you will get Fs is equals to approximately 35342.91 newtons, or in kilonewtons 35.343 kilonewtons. So force acting on the punch is 35.343 kilonewtons. So this is the final answer. Okay.